Hello everyone. In this video, I am now going to start discussing rotational symmetry. I have already discussed axis of symmetry, how I can draw an axis of symmetry, how to continue drawing a shape across a line of symmetry, and how to draw a point and all that things. So we have discussed axis of symmetry already. Now today in this lesson we are going to tell you what rotational symmetry is. One of the most non-understood topic, because we usually do not pay very much attention on this. So now I am trying to make sure that all the things that you need to know about rotational symmetry is discussed in this lesson. Okay, on the left hand side you can see I have written three definitions. I really hope that you can see that. At the top I have mentioned rotational symmetry. First of all, you will have to understand what is rotational symmetry. Rotational symmetry is when an object is rotated around a center a number of degrees and then it looks the same. Means an object or a shape is said to have rotational symmetry when it is rotated completely, and once it is rotated completely, the number of times or the ability that that shape has to appear same as the beginning is called the rotational symmetry. Yeah, symmetry in rotation. Then comes order of rotational symmetry. Order of rotational symmetry is the number of positions or the number of times the object looks the same in a 360-degree rotation, means a complete rotation. So order of rotational symmetry is the number of times the object appears to be same as the beginning in a complete revolution or rotation. Then in the end, angle of rotational symmetry, the smallest angle for which the object can be rotated to coincide with itself, means coincide matlab to appear same as before, to coincide with itself. I have mentioned these three definitions: order of rotational symmetry, order of rotational symmetry, and then angle of rotational symmetry. After I have discussed these three things, here I have few shapes on the board which I am going to rotate and then tell you the number of times they appear to be same as the beginning. For instance, this thing, okay, this might look like a normal ceiling fan. Okay, I want to rotate it completely. Okay, for instance, this is where the top of this shape is. I am going to rotate it and make sure that it comes back at this position. What you have to do is to note down the number of times it looks exactly what it looks right now. The number of times it looks this way in one complete rotation. That will be called the order of rotation. For instance, I hold the top, I can rotate it clockwise and anti-clockwise, no matter, wherever you want you can rotate it. For instance, I hold the top and then start rotating it and then bring it back to its original position. This is one complete rotation. Okay, so you only have to be very careful that the number of times it looks exactly the same. I'm rotating it and this is almost what it looks like as the beginning. Okay, this looks like what it was earlier, but it has been rotated. This was at the top and now it has come at this point. Okay, so this is one time that it looks the same, but the rotation is not complete because this end was at the top. It should go back at the top to make a complete rotation. Okay, I'll further move it to the next point where it looks the same, and this is where it looks exactly the same once again. but still the rotation is not complete. The top end, which was earlier here, it came over here and now it is here. The rotation is still not complete. And when I move it further, and bring it back to the original place where it started, now the rotation is complete. Now you must have observed that when it was here, it came here, here and then back here. When it came back here, in this one complete rotation, it looked exactly like this thrice. So what is the order of rotation of this shape? The order of rotation is now 3 because it looked thrice the same, or it coincided with itself thrice in a complete rotation. So the order of rotational symmetry of this shape is 3. Then I want you to identify the angle of rotation, the minimum angle that this shape required to look exactly the same or to coincide with itself. So how do I calculate it? I knew in a complete rotation the angle is 360. This is the angle of complete rotation, and the number of times it looked exactly the same or the order of its rotation was 3. So for angle of rotation, what am I going to do? Angle in a complete rotation, which is 360, divided by the order of the shape. So 360 for this particular shape, 360 divided by 3. 360 divided by 3 will give me 120. So you can see at an angle of 120, when this object moves 120 degrees, it coincides with itself. Okay? At 120 degree, it coincides with itself once, and when I complete the rotation, it coincides with itself thrice. So what will be the order of rotation? 3 for this kind of shape. Then I have this. This is an equilateral triangle. Okay, this is an equilateral triangle. So when I start moving this, rotating this, okay, sorry, but just give me one more minute. This is where the top is. Okay, this is where the top is. When it comes back here after making the complete rotation, then I'll say the rotation is complete. Okay, so just keep an eye on this point. I'm rotating it. It might look same as earlier, as the beginning, but the rotation is not complete. The top end is right now here, okay? But I have got the first rotation or the first coincidence. Then this. One more time it looks exactly what it looked at the beginning, but the top is here right now. It should go back to its original position. Then I'll move this back to its original position and it will look exactly the same one more time. So again, what is the order of rotation for this shape? The order of rotation for this shape is 3. And what will be the angle of rotation? Angle of rotation is going to be 360 divided by the order of rotation, which will be 120. I have few more shapes here. It's a trapezium, it's an isosceles trapezium, and if I rotate it, let's say this is the point which I am going to keep in mind, and it should come back here. See, let me mark something over here. Okay, this is the point where the shape will come back, and this point should come back to its original position. Okay, I hope you may not be able to see this point, but at least you can keep this point in your mind. Okay, I'm rotating it, and I'll stop when it looks either exactly the same or when it comes back to its original position. Okay, I rotated it at an angle of this is an angle of 90 degree. Okay, but does it look the same? Does it look the same? No, it does not. Okay, then I take it over here. It does not look the same again. I take it over here. It does not look the same. And then when I take it back to its original position, here somewhere here. So it has made one complete rotation, but it never looked the same. So the order of rotation symmetry is either said to be 1 or no order of rotation. Okay, and it's a rectangle. It looks in this form. Okay, so I am rotating it one more time. Just keep any one of these points as your reference point, and I'm rotating it. Okay. It does not look what it was. It now looks the same, but is the rotation complete? I hope you were watching. The rotation is not complete again. and then one more time here. So now at this point, at this point the rotation is now complete. And how many times did it look the same? Okay, what was it like? It was like this or that? Let me do it one more time. Okay, this is how it is. Okay, this is how it is. So one, but the rotation is not yet complete, and two, the rotation is complete and it looks same two times. So the order of rotation symmetry is 2. Then it is a square. It is a square. And what could possibly be the order of rotation symmetry? Yes, 1, 2, 3, and then 4. I hope you have understood. What about that thing? What does that shape look like? That is a regular 1, 2, 3, 4, 5. That is a regular pentagon. Okay, so this is the top, and this is 1. This is now 2. This was my point. This is now 3. This is now 4, and then this is 5. The point on which I fixed it, this point is called the center of rotation. All the objects are moving or rotating around a center, and this is called the center of rotation. This, for each shape, there has to be a certain center of rotation. Okay? After all these shapes, I have got something like this. It's exactly same as this, but there is a difference. Okay? It has an interior. So this thing had an order of rotational symmetry of 3. If I replace this shape, just give me a minute. And if I replace this shape, you have to be very careful with the center of rotation. Yes, and here it is. So, do you think the order of rotational symmetry of this thing will be 3? This rectangle has to be in this form. Okay, and the outer surface has to be this. Okay. This thing has come back to the top, but the rectangle does not look the same. So, at this point, the rectangle looks the same, but the shape is just upside down. And then this again, nothing is like the beginning. And then coming back to the original position. Okay, so when you have a shape that might have an order of rotational symmetry originally, but when it comes with an interior, so you have to be careful what the interior is well. Okay. So 3 things: what is rotational symmetry, what is the order of rotational symmetry, what is angle of rotational symmetry, and one more thing, the angle of rotation, or the angle, I said angle of rotation, the center of rotation, or the center around which the object is revolving. I really hope that now you have a much better understanding of rotational symmetry, angle of rotational symmetry, and order of rotational symmetry. Along with that, the center of rotation. Okay. Make sure that these 4 things are understood clearly. If you have anything that you feel confused about, any shape that you are confused in, kindly try and cut that shape out, find out the center and try rotating it along with it around its center, and then see what is happening. Okay. Hopefully that will give you much better understanding of this thing that you have done earlier, and now I think this will be much more clear than ever before. Thank you so much. Inshallah, in the next video we will now be doing symmetry in 3D shapes. Thank you so much. This was order of rotational symmetry in 2-dimensional shapes. In the next videos we are going to discuss about 3D shapes, axis of symmetry in 3D shapes, and rotational symmetry in 3D shapes. Thanks a lot.